In the Old West, gunfighters studied trigonometry. Oh, duck! Oh, you son of a gun! Why are you? Go! That was close. I think I just go back to doing math. All right, so trigonometric ratios. Yes, I've returned to my own self. The word trigonometry comes from two Greek terms, trigon meaning triangle, metron meaning measure. So a trigonometric ratio is a ratio of two sides of a right triangle. One trigonometric ratio of triangle ABC would be the length of segment AC to the length of segment AB. Okay, so by angle-angle similarity, a right triangle with a given acute angle measurement is similar to every other right triangle with the same acute angle measurement. Therefore, trigonometric ratios are a constant for a given angle measure. So the relationship between, let's say, the distance of the opposite leg, which is BC, over the hypotenuse, which is AB, well, it doesn't matter the size of the triangle. That relationship is going to be constant as we move closer or further away from angle A. Okay, so since those three triangles are all similar, triangle ABC is similar to triangle FGH is similar to triangle JKL. Therefore, AC over AB is equal to FH over FG is equal to JL over JK. Ratios allow us to come up with, the Greeks were able to figure out that with certain angles, then there are certain ratios that develop between the parts. So the first one we're going to talk about is the sine. Sine, and if triangle ABC is a right triangle with acute angle A, then the sine of angle A, written as sin of A, is the ratio of the length of the leg opposite angle A, the opposite to the length of the hypotenuse. Hypotenuse, okay? So sine of A is opposite over hypotenuse, or A over C, and the sine of angle B would be the opposite of the hypotenuse, which would be B over C. So just so we can be clear on this, the opposite from A is there, and the opposite from B is there. Next we have what's called the cosine. So the cosine uses some different parts. And if triangle ABC is a right triangle with acute angle A, then the cosine of angle A, written COSA, is the ratio of the length of the leg adjacent to angle A, the adjacent to the length of the hypotenuse. So you know exactly what we're dealing with. So we're dealing with angle A. Well, what's adjacent? This leg right here, it's right next to it. What's adjacent to angle B? Right here, this measurement, okay? The hypotenuse is always going to be opposite the right angle, okay? So sometimes it helps to label things, right? Which one's the hypotenuse? Okay, next we have what's called the tangent. So if triangle ABC is a right triangle with acute angle A, then the tangent of angle A, written tan A, is the ratio of the length of the leg opposite angle A to the length of the leg adjacent to angle A. So for angle A, here's the opposite, and here's the adjacent. For angle B, here's my opposite, and here's my adjacent. So the secret code word of geometry is SOHCAHTOA. If you memorize this, you can do trig, at least at the elementary levels, at the introductory level. SOHCAHTOA. What does that mean, SOHCAHTOA? Well, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA is tangent, and that's equal to the opposite over the adjacent. So you'll notice the first letter of each of the parts of the code word tells you what trigonometric function you're using. Sine, cosine, tangent, SOHCAHTOA. So, opposite over hypotenuse. Ka, adjacent over hypotenuse. Cosine is equal to adjacent over hypotenuse. TOA, tangent equals opposite over adjacent. Okay. So, the sine of 30 is equal to the opposite. Well, the opposite is x, and over 2x. And x is canceled, which means that that's going to be 1 over 2, which is equal to 0.5. So the sine of 30 is equal to 0.5. The cosine of 30 is equal to the opposite, excuse me, the adjacent, my bad, cosine, ka, C-A-H. The adjacent is x over the square root of 3, and that's going to be over the hypotenuse, which is 2x. So what we're going to do is we're going to cancel these x's out here. And then we're going to end up with, this is equal to the square root of 3 over 2, which is approximately 0.866025, which we're going to round. So this will be 0.87. Tangent of 30 is equal to the opposite, which is x, over the adjacent, which is the square root of 3, x over x times 3, excuse me. And we're going to cancel these out again. And we're going to end up with, this is equal to 1 over the square root of 3, which we're not supposed to do. So we're going to multiply both the numerator and the denominator by the square root of 3 over the square root of 3. And this becomes the square root of 3 over 3, which is approximately 0.57735, which we're just going to round to 0.58. All right. So, how do we do this on a calculator? And I'm going to attach another video basically to show you how you set this up. But basically, or how you can do this on a graphing calculator. So basically what we do is we set this up as we are given here, and we need to label these things. So I have this angle. I'm going to look here. I've got an opposite, and I've got an adjacent. And here's the hypotenuse. Well, I don't have a hypotenuse, so that means we can't use sine, we can't use cosine, so we're going to use tangent. So the tangent of 25 degrees equals opposite, which is x, over 18. So what you do is you can take your handy dandy calculator and you would plug in the tangent, use your tangent function of 25, and you enter that. Some calculators you put the number in first and then hit the tangent key. Other calculators you hit the tangent key and then enter the angle measurement in, and you end up with 0.466308. So this is, we're going to say 0.466308 equals x over 18. Now what we do is we multiply each side by 18. And we end up with approximately, we'll go to the nearest hundredth on this. So x is approximately 8.3954. Let's go to the nearest tenth and say it's about 8.4. Okay. Let's do another problem. Label the parts again. I have a hypotenuse here, right? It's opposite the right angle. 15 is right next to 70, so that's the adjacent. So what am I going to use? I'm going to use cosine. So the cosine of 70 equals the adjacent 15 over x. Now I'm going to show you a little trick here. When we end up with a variable down here in the bottom, what we're going to do is we're going to switch these two out. So we're going to rewrite the problem as x equals 15 divided by cosine of 70. So you can go ahead and plug that into your calculator. And that would be, and you can plug it all in at once if you have a graphing calculator, which you should have. You're going to need one for next year. So 15 divided by, let me use my trig function here, go to the cosine of 70, I hit my enter key, and it tells me that my answer is 43.8571. So x is approximately, let's round to the nearest tenth of 43.9. Now, if you don't have a calculator you can do that with, you're going to have to plug in, hit on an older calculator 70 and then hit the cosine button. So just to give you an idea what that is, cosine of 70, I have a little more advanced calculator here. It's going to be 34202. So if you don't have that type of calculator, you're going to end up with x is equal to 15 divided by 0.34202, and then you would end up getting approximately that for an answer. Okay, so inverse trigonometric ratios. If you know the sine, cosine, or tangent of an acute angle, you can use a calculator to find the measure of the angle. This is known as the inverse of the trigonometric ratio. Find these oftentimes on the calculator using the second key. All right, so it's usually it's the same button, but you're going to have to use the second key to get to this. Okay, so if angle A is an acute angle and the sine of A is x, then the inverse of x is the measure of angle A. So this tells you you plug in the decimal, and then this tells you what the angle measurement is. So the inverse sine, right? I don't know why this is repeating, so we're going to go again. Inverse of the cosine. If angle A is an acute angle and the cosine of A is x, then the inverse cosine of x is the measure of angle A. Inverse tangent. If angle A is an acute angle and the tangent of A is x, then the inverse tangent of x is the measure of angle A. So if the tangent of A is x, right, we've divided the ratio, and we plug it in, and it'll tell us what the measurement of the angle is. So let's do some example problems so you know what we're talking about. So we're going to find the measure of angle A to the nearest tenth. So angle A is here, and we have 18, that's an opposite. This is, and then 27 is the hypotenuse. So we're going to use is the sine, inverse sine of 18 over 27. And that's going to equal the measure of angle A. So how do we do this on the calculator? Well, you take that ratio and you plug it in. All right, so on my calculator, like I said, I've got a little more, I've got trig functions on here. I would go to the sine of -1 and hit enter, and then I would just put in 18 divided by 27. And the calculator does all the work for me. And I've got 41.8103. So the measure of angle A is approximately 41.8. Oops, not 2, David. All right, label your parts. That's going to help. So you'll notice how I set this up. Take the time. You're going to have to figure your calculator out. Okay. Find the measures of angle A to the nearest tenth again. So angle A I am given. Here is the opposite. And this is the adjacent. So I'm going to use the tangent. So I don't know the measurement of angle A, so I'm going to use the tangent. -1, the inverse of the tangent. And I'm going to plug in 6 over 20 equal to the measurement of angle A. So I can just take my handy dandy calculator again, and I'm going to plug in the tangent. So you have to make sure you're using the right formula here. The tangent -1 is 6 divided by 20. And I hit enter. And I get 16.6992. So we're going to say that's about 16.7, right? So the measure of angle A is approximately 16.7. Again, we want to find the measure of angle A to the nearest tenth. So I have the hypotenuse here. This is a hypotenuse. Angle A is here. This is adjacent. So I'm going to use the cosine. So cosine -1 of 3 over 15 is equal to the measure of angle A. So we take our calculator. We hit the trig function. I find my cosine -1 and I pull that up and I plug in 3 divided by 15. I don't even have to simplify it. I just have to plug it in and the calculator does the work. And I find out that the measure of angle A is approximately 78.463, so we'll say 78.5. Okay, now we're going to solve the right triangle. We're going to find all the side measures to the nearest tenth and the angles to the nearest degrees. Well, the only angles we need to find, you just have to pick one. So the first thing I'm going to do is I'm going to have to solve for xy. So we're going to have to use good old Pythagorean theorem for this. So 5 squared plus 9 squared equals xy squared, right? And I've got 25 plus 81 equals xy squared. So 25 and 81 is 106 is equal to xy squared. So now, what do I want to do here? I want to take my calculator again, and I'm just going to put in and find the square root of 106 and plug that into my calculator, and I've got that xy is equal to 10.2956 on my calculator. So it's approximately, because we're going to the nearest tenth, so that's going to be 10.3. Okay, so that's the one. So xy is missing, that's 10.3. Right, so this is 10.3. Now, I pick an angle. It doesn't matter which angle. I know angle Z is 90. That's nice and easy, right? So I can say y or x. I'm going to go with x. So I don't want to use the hypotenuse here. Do not use this. No, don't do this. Okay? Why? Because that's an approximation. I want to go with something a little more exact. So I've got 9 and 5. So the tangent of angle x, right? So the tangent -1, we're finding the inverse, we're finding the angle measurement, is equal to the opposite, which is 9, over the adjacent, which is 5, equals measure of angle x. So take out the handy dandy calculator, and I use my inverse tangent, and I've got 9 divided by 5 plugged in, and I get 60.94, so 60.9 degrees. So the measure of angle, that's crazy. Okay, so we have a little temporary glitch there. So I'm going to erase this junk. All right, so the measure of angle x is equal to 60 point, approximately 60.9 degrees. Okay, well, I don't have to do a bunch of extra work here. I told you pick one angle. I know that measure of angle y has got to add with measure of angle x to make 90. Those have to be complementary angles. So I'm going to know that since 60.9 is approximately 61, that the other angle's got to be 29.1. Okay, I don't have to do any trig. I just got to do some simple subtraction, right? Because 60.9 plus 29.1 is 90. So we've solved all the measurements here that we were missing, right? We solved for xy, we solved for x, and we solved for y. Let's take a look at this triangle, okay? This is a 5, 12, 13 right triangle, right? We talked about these Pythagorean triples. So this is 12. That's simple, okay? Now, since that's perfectly legit, as far as we don't have to, we can pick whatever values we want. So I'm going to pick for f, I'm going to go with f here, and I'm going to pick the sine, the opposite over the hypotenuse. So the sine -1 of 5 over 13. I hate when my letters don't come out, things don't come out right on the drawings. Is equal to the measure of angle f. So here we go. Trig function, inverse sine, and that's 5 divided by 13. And I hit enter. and I get 22.6199. So the measure of angle F is, so the angles are the nearest degree. So the measure of angle F is going to be 23, right? Because we're going to the nearest degree. So the measure of angle F, 6 rounds up to 23. So it's going to be approximately 23. So the measure of angle G, that's always easy to figure out. It's approximately, we'll just take 90 and subtract 23 from it, and you end up with 67. So it's almost 67 degrees, give or take a few tenths. All right, let's solve this one. Okay, so now we are only given one length, right? So we have one angle, 62, and the hypotenuse. So angle C is pretty easy to find, okay? That's going to be a whopping, this is going to be 28 degrees. That's easy, right? That's, low-hanging fruit right there. 62 plus 28 equals 90. But now we got to find AB and BC, and we're going to have to round those to the nearest tenths. So we know the hypotenuse, so we can use sine or cosine. So let's go with 62 here, angle A. So the sine of 62 is equal to the opposite, which is BC over 10. Okay, so we have the sine of 62 is equal to BC over 10. So we just plug in the sine of 62 and hit enter, and it tells us that that's equal to 0.882948. And we're going to go to the nearest tenth. We're going to go to the hundredth here. So 0.88, and this is equal to BC over 10. So we just use our algebra skills here. We're going to multiply each side by 10. And we end up with BC is approximately 8.8 in length. So now we have to do AB. Well, I'm going to stick with 62 degrees here, and that's got to be a cosine, right? Because AB is adjacent to angle A, right? Angle A is adjacent to AB. So the cosine of 62 is equal to AB over 10. So we're going to go ahead and plug that in now into our calculator. And I plug cosine of 62 in there, and I get 0.469472. So I'm going to go with 0. I'm going to go to the hundredths here because we are rounding. Actually 0.47, because if I round to the nearest hundredth, and 9 is 1,000. So is equal to, let's say, AB over 10. And I multiply each side by 10 just like I did before. So AB is approximately 4.7.
That's all, folks.
Gotta pick up those mad calculator skills, boys. Talk to you soon.